Algebra 2s. I have a lot of this already written on, so you're going to pause it and copy it, but first I'm just going to explain it, okay? So we talked about this today. This was literally the lesson that we did today in class for day 6, how factors are opposite the roots, okay? We set them equal to 0 and solve to get those roots. So the remainder theorem is if I ask you to take a function and divide it by something, okay? If there is a remainder, we put that remainder over this, over that divisor. Okay, this was everything we did in yesterday's lesson. I then showed you a remainder theorem check. The remainder theorem is, if x minus 2 is what is being divided, then you take the root of that, which is 2. That's your part B. Okay, and find the function at 2. If I substitute 2 into the original function that was given, you get 24. So this was your check today in class, that this remainder and this were the same. Remember? And I mentioned that if you get a remainder, which means that the function at 2 is not 0, then 2 is not a root, and x minus 2 can't be a factor, okay? Because the other word for root is 0, or solution, or x-intercept. Remember that? That was a couple days ago. So this is basically what we're doing. We're trying to see that if we divide this by what we think could be a factor, but we get a remainder, then we know that this is not a factor, as well as 2 not being a root. Okay? So if you need to pause this to copy this down, you can. And I'm going to move on. Okay? So hopefully you unpaused it by now and had copied that down. If not, rewind it and copy it after we're done. Okay? So the next example is giving you a new function and asking you to divide it by x plus 1. So if I do that, this is what I get. Okay, x squared minus 4x plus 10 minus 2 over x plus 1. So that's telling me that this couldn't have been a factor because I had a remainder that had to have a fraction at the end. So if I take the opposite of this, which is -1, and I substitute it into my original function, I should get that same -2 that I got here, -2. Okay, which again is telling me that x plus 1 is not a factor of the function, and -1 is not a root of that function. Okay? So again, this is everything we did yesterday. So you can just circle number 3, and we will do that tomorrow as a do now to make sure that you guys definitely understand it. Okay? So make sure that those are copied down into your notes. And if you have any questions, of course, we'll go over it tomorrow. Okay? So now let's actually do the lesson. Okay? So the lesson is applying all of this. So I started writing this, what you should know from the lesson. So it says, consider the polynomial p of x is this. Notice there's a k in there, not a number. So part A is saying find the value of k so that x plus 1 is a factor. Well, if x plus 1 is a factor, then -1 must be a root. So we're going to use the remainder theorem and find p of -1. If they're telling me it's a factor, that means there can't be a remainder. That means it has to equal 0. So that means if I take -1 and substitute it into each of these x values, I should get 0 as an answer. So -1 to the third plus k times -1 squared plus -1 plus 6 should equal 0. So this gives me -1 plus k, -1 squared is 1. So 1 times k is k. minus 1 plus 6 equals 0. That gives me k negative 1 minus 1 plus 6 is 4. Move that over, I get k equals negative 4. So that means negative 4 is what k is. And that's all they asked you to do. Okay? That's your answer. But part B to this is saying find the other two factors. Well, that means that x cubed minus 4x squared, see what I did? I took the negative 4 and put it where the k is, plus x plus 6 divided by one of the factors. Okay? They're asking you to find the other two factors. How do we know there's two? Two more? Because here's one, and it's x cubed. So we know there has to be three factors, right? One, and then two more. So you would take this and divide it, which is what you did 3 weeks ago. If you divide this, you get x squared minus 5x plus 6, no remainder. So they asked for what are the other two factors? Well, first week of school, we learned how to factor that. That's factoring IM. Okay? So what that's telling us really is that x plus 1 is a factor, x minus 2 is a factor, and x minus 3 is a factor. If they wanted to, they could even ask you for what all the solutions are. It'd be negative 1, positive 2, and positive 3. Okay? So that's the actual application of this whole lesson. So let's see one example that would be like what you would see on a Regents. Okay? So this would be like a part 4 type question on the Regents, or maybe even a part 3. So they're giving you the function, and they're asking if 1 is a 0. Well, if 1 is a 0, that would mean if I substituted 1 in, I would get 0. So substitute 1 into this equation. 1 to the 4th plus 3 times 1 cubed minus 28 times 1 squared minus 36 times 1 plus 144. So we would type that into our calculator, okay, which I think I already did when I checked it a moment ago. Hold on. Yep, there we go. Okay, so 1 to the 4th plus, this is everything substituted in that you just saw here. Okay, so you would type that in, which we did in class, and we got 84. So if P of 1 equals 84, then the answer is no, because P of 1 does not equal 0. In order for it to be a 0, I have to get 0 when I substitute. Okay? So now they want to know if x plus 3 is a factor. Well, if x plus 3 is a factor, then x equals negative 3 must be a root. So we're going to do the same thing, put in a negative 3 into the whole equation. So negative 3 substituted in, negative 3 substituted in, negative 3 subbed in, negative 3 subbed in, type all of that into your calculator, get your answer, which does happen to be 0 this time. So that tells me negative 3 is a root, and that is a factor. So x plus 3 is a factor because the remainder theorem equaled 0. Okay? So the next part of this is the graph of P is shown to the right. What are the zeros? Well, the zeros are where it crosses the x-axis, because we said zeros, another word for zeros, were roots. That's where it's rooting into that axis, or x-intercepts, or solutions, right? So they're showing you this is 5, so this is 4, 3, 2, 1, -1, -2, -3, -4, -5, -6. So my roots are -6, -3, 2, and 4. So it's asking, what are my zeros? Same thing as the roots. -6, -3, 2, and 4. So now they want you to write the equation in factored form. Well, if these are the roots, then the factors are the opposite. X plus 6 is one factor. X plus 3 is another factor. X minus 2 is another factor. And X minus 4 is another factor. But they asked for an equation of P. So P of X equals, then it's an equation. Okay? So not too difficult. Straightforward. We know our roots are always opposite our factors. Okay? Let's move to the last problem. The last problem, very similar. They're telling you the degree is 5, and notice we have 5 roots. So if they're telling me their x-intercepts are these 5 numbers, remember x-intercepts are roots. So it wants you to write a formula for a possible polynomial function that the graph represents using c as a constant factor. I'll talk about what that is in a minute. But we should all know that if these are the roots or solutions or x-intercepts, the opposites are my factors. So the polynomial, and they didn't tell me what to name the polynomial, so we could say it is either f of x, or we could say it is y equals. The first root was -4, so I'm going to put x plus 4. The next root was -2, so x plus 2. The next root was 1, so x minus 1, always the opposites. 3 would be x minus 3, and 5 would be x minus 5. Okay? So they're saying use c as a constant factor. That's a little new thing right now. And what they mean by the constant factor is you're going to put it here. We typically name it a, not c, because we don't know what type of stretch is going on here. Okay? Remember, you're stretching in Algebra 1 with transformations? So this, here's my -4. This, here's my -2. This is my 1. This is my -3. And that, I'm sorry, +3. And this is my 5, right? Do we notice there's also a y-intercept this time? I just want to talk about that briefly. The y-intercept is found when we have the x as 0, right? X equals 0 right here the whole way along. So my y-intercept is found by substituting in a 0. So if I were to plug in a 0, I would have c times 0 plus 4 times 0 plus 2 times 0 minus 1 times 0 minus 3 times 0 minus 5, which is really giving me, if you multiply all that together, we get a -120. Okay? That doesn't look like a -120. Not if over here is -10 to 10. There's no numbers along this axis to tell me what interval it's at. So this could be -120. But you notice in the next one, it's telling me that suppose my y-intercept is -4. They want to know what the value of C is. Well, right now we did all of this. We multiplied this. And if I multiply it by C, they're telling me that that should be -4. So -4 should equal -120C. If I solve by division, C is equal to 1/30. Okay? Now you could check that. Remember what we said the function was equal to? F of x equals C, which we just said is 130, times x plus 4, and x plus 2, and x minus 1, and x minus 3, and x minus 5. Oops. If you put this in f of x and put it in your calculator, which I had done for you already here, this looks just like that. Okay? That's what that C value is. We'll talk more about that. That was a little bit tricky, and if you don't understand that, it's okay. Don't worry about the C value. But you do need to know how to go from roots to factors, and you also should know how to find a y-intercept. Even if I didn't have the C here, you should know that you would substitute in a 0, and it's whatever all your x, when you plug in the x equals 0, you just multiply all those numbers to find that. That was something you did back in Algebra 1, okay? So, little lesson summary, read through that, and tomorrow in class, we're just going to start this homework assignment, okay? All right, have a good night.